So let me ask you a question. Have you ever heard of a Hilsch Vortex tube? Now don't answer that because I wouldn't be able to hear you. Now this is not a Vortex tube. This is just a 4-inch piece of 1-inch aluminum tubing. But this, on the other hand, might be a Vortex tube. And we'll get into that in just a minute. Now I'm a little apprehensive about this build. Nervous, anxious maybe. Because, quite frankly, I'm trying to build something that I have no intuitive understanding of how it works. For all I know, I could be building an interoscillator. What you see here is essentially my best guess, based on the very little that I know or I could find. I mean, it's not that complicated. It's only about 6 pieces, all of which are pretty straightforward. But we'll get back to this. For now, let's just take a look at what a Hilsch Vortex tube is. A vortex tube is sort of a T-shaped device that takes a single stream of regular old compressed air and magically separates it into two, a hot stream and a cold stream. Let me say that again. Compressed shop air comes in the side and you get hot air on one end and cold air on the other. I mean, it's almost as unbelievable as the McBLT box from the 80s. With absolutely no moving parts, it keeps the cold side cold and the hot side hot. Now, these aren't just a gimmick. These are available commercially. You can buy a small one for about $100. Apparently, they can turn 90 psi shop air from your compressor to 200 degrees C on the hot side and about -50 on the cold side. Terribly inefficient, but they'll do it if you're willing to put up the air. So we'll get into how a vortex tube does this, but as I mentioned, I haven't quite gotten my head around it myself. So take what I say with a grain of salt. It was invented in 1931 by a fellow named Ranque, so they called it the Hilsch tube. What a bum rap he got. Though the more I read about it, the more I'm convinced it was a pact with the devil. Now if you're anything like me, you're probably thinking $100 for a tube with no moving parts is a little bit expensive. But I think they're making you pay for two things. The black magic that's inside, and the fact that they probably never break down. I mean, unless you're pumping like mud through them. I assume they'd last forever. In this design, there are 6 parts. I've got the material rough cut. There are still a couple of odds and ends on the back end there, but these are the major pieces. I'm going to start with the cold end nozzle, which you see in blue here, and along the way we'll chat about how I got here. So the majority of these parts are quite simple, and to be honest, even the complicated ones, relatively speaking, aren't that difficult either. Just a lot of concentric turning, getting stuff to size so everything goes together. I'll be sure to cover some of the subtle details. Since this part is a little bit wispy, I've roughed out the back side. I'll size this side and then flip it around again to finish that off. I usually use WD-40 on aluminum parts, but whenever I come across like haunted parts or parts of demonic origin, I like to break out the special formulation. All the help I can get. The cold side nozzle's done. The hot side tube fits to that small step there. And there's another ring that helps keep this all together. All of this lives inside of this tan block here. That's the part I'll make next. The combination of these parts creates what's called the swirl chamber. Let me make this and then we'll talk a little bit more about what I think is going on the insides. The only really important features of this block are all on the inside. That'll be all cylindrical lathe work, So I figured I would just square it up here in the forejaw. Not perfect, but close enough for what I need. So this is one of the two pieces that creates the swirl chamber. This is sort of the antechamber where the air can come in and, take off its shoes. It's just got a couple of steps. There's a hole in the back that just fits the hot side tube, and a step and a bore at the front for the cold side tube. Now the air comes in tangentially here, so it induces a swirl in there. Now, for some reason you can't see this part of the video, YouTube may have blocked it, as creating a vortex might not be legal in your country. So as it is right now, air can't really get into this center tube. There's no opening into this horizontal section yet. And that's what this collar and series of holes will be for. Let's make this small ring, press it onto the tubing, and drill 6 tangential holes to complete the swirl chamber. These are 6 evenly spaced holes. They're 60 thou, 1.5 millimeter. This fits into the housing. Pardon me just a minute. Hello. Hey, is this Adam? Yeah, nothing that can't wait. But calm down, calm down. Take a deep breath. What's going on? What do you mean the lathe won't run? Well, is it plugged in? Just go check, see if it's plugged in. Alright, you all good now? Alright, yeah, no problem. Talk to you later. So compressed air comes into sort of this pre-chamber. It's already swirling. I don't know even how important that is. Fills up that chamber, and the only way out is through these 6 holes, sort of the 6 jets. This end, remember, is capped with the cold side nozzle. When air comes into those jets, it sort of hits this 10-degree wall and just helps it along a bit to make that 90-degree transition to come down the large tube. So the air is formed into a vortex and sent that way, to the left in this case. On this end, again the end that should get hot, there's just a bit of a small valve. In principle, you adjust the valve until you get the temperature difference that you want. To hold the valve in place, I made essentially like a valve body / breather cap. Just a cylindrical cap with I think 8 slots around the perimeter. This is what slots look like when you don't lock the rotary table. The valve screws on here, and that gives me a way to adjust it in and out. And this whole mess fits on the end with 3 screws. Now, I'm not sure yet, but I think these screws should be long enough to do the job. Okay, so we said we have a vortex of air coming down this large tube, and it runs into a valve seat. Depending on how open or closed that valve is and how much pressure you have coming in, you set up sort of a pressure difference in this tube. Now here's where my speculation begins. Again, take this with a grain of salt. Because of that pressure balance, at some point the air that's coming down the tube in sort of that spiral vortex turns in on itself and creates a smaller vortex rotating the same direction but traveling the other way. So there's a larger vortex coming down towards this end, smaller vortex in the center going out the other end. And as it so happens, these 2 vortices create a temperature difference. Hot air comes out this way from the larger diameter vortex, and cold air goes out that end from the smaller diameter vortex. Now, instead of trying to get into some technical mumbo-jumbo here, if you're interested in why that happens, sort of the phenomenon, like the physics of it, just go ahead and do what I did and Google it. I wasn't able to find the clearest answer in the world, but there are some interesting white papers out there that talk about it. Now, the hot side tube is actually longer than what I'm showing you here. It'll actually be a combination of these 2 tubes, and the valve will be down on this end. Before I get into that, let's talk about how I got here. Now, there doesn't seem to be, or I haven't been able to find, a lot of information on just how to go about building these things. In order to show you how I got to what you're looking at, I'm going to have to get a little sciencey on you and jump into the computer. So if you Google Hilsch Vortex, you're likely to get one of 3 results. The first is outside the scope of this video. The second and majority of information that you find will be plans or recipes for building vortex tubes using standard hardware, like plumbing, usually PVC pipes, washers, tape, glue, that kind of stuff. The third thing you'll find is like scientific papers that are a little bit out there. I mean, interesting reads if you're into that kind of stuff, but it's more performance and efficiency, not so much dimensions on how to build one. That said, I ended up working from Ranque's original patent drawings and some information I found on rexresearch.com. The drawings are interesting. It looks like he worked with a few different ways of inducing the vortex, but the site includes an interesting drawing from the US Navy of sort of a pipe fitting type assembly with a spiral chamber in the center. Some more stack-ups of, how you might construct one of these. But what I found most interesting was a chart at the bottom of the page that showed some of Hilsch's results. In my particular case, I went with tube number 1 here, and some of the diameters listed, more or less. I kind of rounded it to get to the material that I had on hand. I then modeled that in SolidWorks and geeked out a bit with some flow simulations. Now, I can't predict a temperature drop here, so I don't know how good of a guess this is. I mean, I do get a temperature drop, but it's a different effect than what I think is happening in the vortex tube. I'm seeing more like the expansion of air through a nozzle, kind of like what happens when you shoot air out of your air gun in your shop. So I started here and I tried to modify the geometry so that the air moving through the chambers did so sort of as smoothly as possible. And after a lot of screwing around, I ended up here. That should look familiar. I added a couple of features in the cross section here, again, just to sort of help the air get to where I want it, reduce some of the recirculation and the chaotic looking flow that happened right as the air transitioned from the compressed section through the spiral chamber and out the tubes. And if you look closely, you can see where the vortex inverts on the inside and starts to head towards the cold section. Again, I wasn't able to predict what it would do temperature-wise, so I'm just going to have to build this out and see. Fingers crossed. Now I'm not sure if this move here is ballsy or stupid, but a more smart person than I may have bolted this thing together. Hello? You got your what in the vise? What was he even doing out in the shop? Truth be told, I've never been that good with these small diameter welds, especially on aluminum. And of course, this happens to be the perfect storm too, with thick, heavy aluminum block being welded to a thin-walled tube. Had I broken through on the inside, or gotten even a little bit of weld buildup come through, I don't think this thing would have developed the vortex that I needed on the inside in order to open the time portal to get me back to my family. I suppose there's nothing much left than to try this out. To get the whole hot side tube on, I made a little plastic sleeve. Hopefully the pressure doesn't blow this apart. I also made a new valve body. I wasn't quite happy with how the aluminum one fit, and I had the plastic in the lathe to make the adapter for the hot side tube, and I thought I'd knock this out. Same concept, set screws, and that's the same sort of cone seat in there. I'll be honest, I'm having some doubt about my material choices. I don't know if aluminum is the smartest thing in the world for a device like this. I went with the aluminum because it's a smooth bore. There's no seam on the inside of the tubing. I have it in a few different sizes and it's easy to work with. I'm wondering if its thermal conductivity will be a problem given maybe how much air I can push through this with my compressor. Anyway, talk is cheap. Let's give it a try. Alright, so let's see if you can't pick up on what I'm laying down here, Daddy-o. I've got the tube mounted in my bench vise with a piece of, I don't know, 1/8 inch rubber or so, just try to keep it insulated. No idea if that actually makes any difference, but sounds kind of smart. I've got 3 thermocouples tied to the tube. I've got a dual channel thermometer brand thermometer. My X-Tech multimeter will take a K-type thermocouple. I'm using 3 because I have 3. If I would have had 5, I would have probably attached all 5. Now you may note some discrepancy in the numbers. This thing's reading about 18 degrees C, and that's 4 degrees C higher at 22, though everything here is all the same temperature. It's the temperature of my garage. Just for reference, it's about 64 degrees Fahrenheit and about 18 degrees C. I consider myself a democratic sort of guy, so I'm going to go with the majority vote here and call it 18 degrees. Now, I'm not sure how linear that error will be, but it's not really a big deal. I'm looking more for like the general effect of Vortex tube and not trying to split hairs on what the exact temperature is. The dual channel thermometer, the blue leads are going to be watching the far ends, the hot side and the cold side. These would have probably been better like in the hot and the cold air streams, but that would have been tricky to set up. So they're just on the outside of the aluminum tubing. I figure if this runs for a little while, it should be pretty close, temperature-wise. The X-Tech is watching the center. In the flow simulation, at this length of a tube, the vortex inversion happens somewhere in the middle here. So I'm going to put on my hearing protection and attach the compressed air. At that point, I think you'll be seeing the temperature readings. I've got a camera on the pressure gauge on my airline, and you'll be looking at a thermal image of this whole setup. Here goes nothing. Now the thermal image looks a little funky. I've had problems with the auto ranging on this thing. Like I just can't turn it off. It says it's off, but it just auto ranges. So it looks like the hot side's already hot and the cold side's already cold. But even a 1/10 of a degree difference kind of throws the whole scale. If you can make it out, pay attention to the temperature of the plastic parts and maybe the electrical tape if you can see it. Shiny aluminum also isn't great for infrared thermometers. I gotta say, this is wild. The cold side being cold, for some reason doesn't impress me as much as the hot side being hot. The center here is very hot to the touch. The air coming out the back is warm, but the center feels hotter to me. Now, if you're watching the pressure gauge, you may have noticed that my compressor can't keep up with this vortex tube. I may have made this vortex tube a little bit too big. The compressor looks like it flatlines around 70 psi. The compressor itself is set for 120 psi, or about 8 bar. So I don't know how well you'll be able to see this. Keep an eye on the temperature there in the background. It looks like the very center of the exit on the cold side gets down to about, wow, like 1 degree. And it's very sensitive. If I move off of center even a bit, it'll jump up 4 or 5 degrees. Alright, so quick recap. Vortex tube, seems like it's working. It's doing something anyway. Though I'll be honest, I have mixed feelings. Pardon me. Hello? Come again? Oh yeah, of course I do. Chris, right? How's everything down there? Good, good. What can I do for you? Sure thing, just a sec. It's about 12:26. So anyway, depending on how you interpret those results that I showed you, it looks like anything from a 30 degree to a 50 degree temperature difference across the tube. I was seeing a hotter temperature in the center here, pretty close to 50 degrees C, and it was down to about 40 by the time it reached the end. I'm going on memory here. And in the back, the cold side on the outside was 8 or 10 degrees, and the center of the stream was down at about 1. Depending on how you take those numbers, you get sort of a different assessment of the build here. But as I was saying, I have somewhat mixed feelings about this because I think it really only goes to show that I can sort of follow directions. I don't know what knobs to turn here, for example, if I wanted a hotter hot side or a colder cold side. No pun intended there, I don't mean the valve at the end. I mean the effects of diameters and lengths. You see a lot of information online with tabulated data of different combinations of those, which leads me to believe that the physics of what's going on here, I don't want to say isn't understood, but maybe isn't clear cut. And those commercial units, what are they doing inside one of those to get them so small? This thing's almost 3 foot long. Are they somehow wrapping that vortex on itself 3 or 4 times and just folding it until they get a really small package? Not a clue. Be interesting to break one of those things down. Anyway, if anyone's interested, I'll put the CAD of this build in the description. I hope you enjoyed the ride, and as always, thanks for watching.